All right, so this is meant to be a really, really fast review so that I can get into your packet with you. Here are some of the topics that we need to know for the final. For factoring, the easiest kind all the way to the hardest kind of factoring. Do you remember divide and conquer kind of factoring where you have 4 parts to the problem? Like for instance, 2x squared, no, x to the third, plus 4x squared plus 6x plus 12. Do you remember how to factor 4-part things? If you do, give this one a shot. You divide it down the middle, and you say, what goes into both of those? X squared does, and so does 2. So I go 2x squared comes out, and then what do I have left? X plus 2. Okay, and then what comes out of both of these? 6 does. 6 comes out to the front, x plus 2. And then do you remember how these are the things that are in common then, and then they come to the front? So they have x plus 2 in the front, and then what's left after I get rid of them? The 2x squared plus 6. That's 4-part factoring. That's the hardest kind of factoring that you would encounter. Right? Do you want me to do another one of those or not? All right. And yes, you may. Oh my gosh. You can go to the nurse if you want to. All right. Okay. Next up, 6x to the third plus 18x squared. Let's see, minus 4x minus 12. See if we can do that one. Gentlemen, problem on the board. Give it a shot. Divide and conquer. You got 4 parts, you got to divide it up into chunks. Split it right down there. First 2 terms and the second 2 terms. If you're having trouble with the first 2, start with the second 2. What goes into both of those? Negative 4 does. X plus 2. And the first part, what goes in both of those? 6x squared does. What do I have left? X plus 3. And do you think it's a coincidence that there was one of these in each of them? No. So those can come to the front now. And the final answer I'll write in red. You put x plus 3 in the front, and then what's left after you take those guys out is 6x squared minus 4. What? No, it would not. You remember how I took a 4 out of both of these? Did I put 4 squared? No, because that 4 is going to get times back in both spots. So you're still going to use the 4 twice. But you don't need to just say squared up. Nope, because this is just factoring. If they had asked for an equation, you'd write y equals, because the equations always need a y equals. All right. Solving absolute value inequalities. We just got done with the whole test on that, so let's not talk about that. Absolute value equations, though, do you know how to solve this? What do? Split it up into 2 parts. Remember this? 2x minus 3 has to equal 5, or 2x minus 3 has to equal negative 5. Remember that? And then you solve the 2 equations. So absolute values always have 2 answers. Think about it. What's underneath here can either be 5 or negative 5, right? So we take what's underneath there, and we say it's 5, or what's underneath there is negative 5. Then you solve those 2 equations. All right, moving on. Functions and domains. You remember how we'd have functions like f of x and g of x and that kind of stuff? And we remember how we had to figure out their domains? All right, what's the domain of this? Domain just means what works. Everything works. Yeah, all reals. Everything work in this too? Yeah. What if I'd have said over x to the 5th? Then not everything would work. One thing wouldn't. 0, because you couldn't have it crash. And the other thing they have is sometimes they have square roots like this. Let's say there was a square root. Then the key moment is where it's equal to 0. So you'd say 2x minus 1 has to equal 0. But I want it to be bigger than or equal to 0. So you'd solve that little equation to find its domain there. Okay? And how about if I do g minus f of x? That means I take f of x and I take g of x. And I put the one function and I just subtract the other function. The g comes first. And then the f of x function, or which I'll put in green, I subtract from it. Actually, I put the minus sign in green, and then the g of f function, or sorry, the f function I'll put in blue, 2x minus 1. So now I'd need that in parentheses so that that negative can get distributed. And my final answer would be x squared minus 2x plus 1. One little negative is all the difference in the world. I had so many people make just one little negative in the wrong spot on a lot of their problems on the test. Overall, it was pretty good, but the mistakes that were made, I'm serious, like half of them have to do with just a negative sign. Forgetting these parentheses means you're just going to screw up your negatives. So be careful with your negatives. Okay, moving on. Do you remember making an inverse? An inverse is something where there were 3 steps, and you had to start by changing the f of x to a y. Remember this? And then how do you get the next step? You switch the x and the y around, so it's now x equals square root of y minus 3, and then what do you solve for? Y. Because we already had to solve for x, we need to solve for y now. And so then, how do you get rid of the square root? Square both sides, and that cancels that. And I'd have x squared equals y minus 3, and then how do I finish? Add 3. We're just trying to find the... We don't want to get x alone, we want to get y alone. Because we had y alone at the beginning, now we need y alone again. So we're trying to get the y alone, so we add 3 to both sides, and now we have y is equal to x squared plus 3. If you look at what we had originally, we had a square root and we had a minus. Now we got a squared and a plus. Do you get how it's inverse? All right. I'd like you to do one of these. If you just watch me, you're not going to learn anything. Let's try this square root of 2x minus 5. I want to know what the inverse of that would be. Square root, so I have to square both sides. And then, well, not too bad. Add 5 both sides. And then I get 5 by 2. This one's got a divide in it, the other one had a multiply. This one's got a plus in it, the other one had a minus. This one's got a, well, it's got a squared in it, and the other one had a square root, so it kind of makes sense. This is an equal sign, if that's what you're asking. Okay, when you are at this moment right here, you have to get the y alone, and you'd ask yourself, should I get rid of this or that? And you just use the normal order of operations to undo things. You're undoing stuff, you're not doing the normal order of operations, you're doing the opposite of it. So bottom line is you always get rid of your add or subtract first, and you do your multiply or divide last. That's the normal way to solve equations. You always solve equations in the opposite of the order of operations. So normally you'd say, please excuse my dear Aunt Sally, and parentheses should come first, exponents come next, multiply and divide, they're third, and the last thing you do is add and subtract. When you're solving equations, the first thing you do is your add and subtract. Okay, moving on. Mixture problems. I know you didn't see any, but I think there's one on the final. So make sure you know that formula. I've gone over it with you like 5,000 times. I don't think we should even do another one right now. Moving on. Projectile motion. Do you remember what kind of problems those were? What kind of equations were they? Quadratic. And a typical problem would look like this. And then you'd have to figure out the vertex and the axis of symmetry and all that kind of stuff. The main thing would be if a ball was launched on the surface of the moon and it was thrown upwards at a velocity of 2 feet per second, how long would it take before the ball would hit the ground? That kind of thing. Well, to do these projectile motion questions, there's really only 3 things they could ask you about. One is the vertex. And if you have a graphing calculator for the final, which you will for at least a lot of it, you know where to find the vertex? You just graph the thing. And then you go, once you got this up on your graph, and it looks like this, how do you actually find out where that spot is? Second, calculate the maximum. I think it's been too long for you guys. Why don't you graph this one, please, on your calculator real quick. Graph that puppy. It's a parabola that's upside down. You can tell because it's got a squared in it, and then the negative in front means it's upside down. And see if you can find the highest spot of it all, the vertex. It'll be good if you can then do second, calculate maximum. It's more important to draw closer. Grab. Hi. Again. So once I graphed it, it came up like this, and what am I supposed to do with that now? What is the answer? The answer is the high spot. Well, I can't see it very well, so I'm going to do a zoom out. And remember, as soon as you do zoom out, you have to tell it where to zoom out from, and I'd really rather zoom out kind of more up here. I'm moving the little plus sign, and then I can zoom out there. If you just hit enter again, it will zoom out, but it kind of is a dumb zoom out. I'm doing a smart zoom out. Now, I really can't see that terribly well, so I'm going to do one more zoom box. I like the zoom box a lot, and I'm going to use a Z box to see the graph better. Enter. Oh, come on. Okay, this thing is really slow. Zoom box. Enter. Box over. Only the very top of the box is all I really care about. It's where is that high spot? Okay, so where is the high spot? I go second, calculate the maximum. And then I go left bound. That means get the little spider to be on the left side. So I am on the left side. Now I'm going to go get the spider on the right side. I'm going to move the spider all the way until it goes past it, up and over, and there it is. It's on the right side, and I hit enter, and it says guess. That means I get close, and I hit enter one more time, and there's my maximum at 0.062, and the maximum it was 7.06. So the point is, this was it was 7 feet off the ground in the first place, and the highest it ever went was 7.06. So the point is, it never went up very high. Why didn't it go up very high? Because when I launched it, its velocity is right here. The velocity wasn't very high. It was pretty slow. All right, so hopefully that reminds you of some of your calculator skills you'll need. One other thing you can do with it is if they want to know where it is at time 1.2 seconds, how do you do that? Your time is your x numbers. So if they want time to be 1.2 seconds, you want x to equal 1.2. How do you do that? You go to your calculator, and you go second, calculate, and which one of these do you think it is to tell it 1.2? Value. Yes. Calculate the very top one, value. And know what pops up? X equals. And it blinks. And it's saying, what value do you want? I want it to be at 1.2 seconds. And it tells me your answer would be negative 18.44. The point is that this was only in the air such a short period of time that it's actually, if you looked at a graph of it, after 1.2 seconds, 1.2 seconds is like here. It's way down in the negatives. So this thing wasn't even in the air that long. What's the other thing you can calculate? Besides calculating a value, you can calculate that spot. That's called a zero. Remember the zeros? The roots, the x-intercepts? Calculate zero. We'll tell you that. Okay, question. In the back row. Okay, good. All right, we got to move on. There's a whole bunch of kinds of regression. Almost everybody got the regression questions right on the test that I'm going to give you back in a minute, so we won't even bother with that. Good job. Radical equations. What if you have a square root in your equation? What does that make you do? Well, let's try this one. Everybody solve this one. See if you do it right. Radical equations. First step is you're trying to get the x alone. So you really need to get that square root alone. If you can get the square root alone, then you'll be able to square it to get rid of the square root. So I would take away an x from both sides. Then I would take away a 1 from both sides. Take away a 1 from both sides. Negative 2 square root of x plus 4 equals negative x minus 1. I'm almost got the square root alone, but it still isn't alone. I have to divide by -2. And that gets the square root alone. And there's what I have. Now, yes, we divided it by a negative on both sides. But yes, you could figure out what this is, but I'm going to leave it as a big fraction. You could do it either way. Now, we have to square both sides. Get how squaring gets rid of square roots. So I'm going to square both sides. What does squaring mean? It means times it by itself. All right, so that gets square root off of there. X plus 4 equals, this would be a pain in the butt. But it's something you're going to have to handle. Over -2. And then I times it by itself. The bottom part of that will be easy, because -2 times -2 makes +4. But the top part's going to be a bit of a pain. You're going to have to distribute that out. It's going to be long and difficult. All right, kid with first name B in the yellow shirt, that goes in my desk, not in your pocket. On my desk. Thank you. Stay focused on your math right now. All right, moving on. I don't want to say names on the tape. That's why I went that way. All right. So, I do know his name. Moving on, we have put equations in vertex form. That's completing the square. A shocking number of kids did not know how to complete the square yesterday. So I want to go through one of those with you. Look at this one. And I know some of you already know how to complete the square. But for those that don't, please follow me step by step. Everybody please follow me step by step. But I'm doing this because there's some people that really stink at this still. And it's going to keep coming up. All right, so I'm going to take the -2 out first. And I'll have x squared minus 4x. You get why that's minus? Because if I multiply this in, I'll get this. And this times this, I'll get that. All right, and now that -3 just gets kicked all the way over to the right. You move it over there for now. And then we need plus a line and minus a line. And this part right here is the part that has to be the perfect square. Who helps us figure out that spot right there? Huffman squared. Half of the 4 is 2. 2 squared is 4. 4. And then, what's the mistake that everybody forgets? The 2 here has to go there. And a lot of you in the assignment or the test yesterday, there was a negative out in front here. Did you remember to put a negative over here? Most of you didn't. Okay, anyway, or many of you didn't. Okay, so the -2 goes here, and then I times it like that. And then a final answer would be y equals -2, parentheses, x, and this part right here becomes -2 squared from all of that. And then this part becomes positive 4 times 2 is 8. 8 minus 3. There we go. That's completing the square. You get that? I hope you do. Now, why did I do that? Because now I have the vertex. The vertex is right here. There and there. And it's -2, but it actually turns to +2. So you do the opposite of what's on the inside. And 5. So 2 times 5 is the vertex, and x equals 2 would be the axis of symmetry. All right. On that note, this seems like a good time to hand your test back, so I'm going to record it just a little bit more here. If you turn in your packet to problem number 4, I'm going to show you how to do those domains. If it's just like f plus g, or f minus g, or f times g, all you have to do is take the 2 domains and overlap them. Do you remember how this works? You make a number line for each domain, the domain of the f and the domain of the g. You just overlap their 2 number lines, and it's that simple. But when it's f of g of x, that kind of a number line, or f over g of x, when you divide them, you have to have a 3rd number line, and that's the number line for where this one, the g function, cannot equal 0. So you figure out what would make the g function ever be 0, and it can't do that because you can't have a 0 down here. So you need to overlap 3 number lines for this kind of a problem. And then for the ones that are like this, f of g of x, do you remember how to do it where you have 2? There's 2 things you have to check. For the domain of this thing, for the domain of this, I know you're kind of burned out, but stick with me. This is probably the hardest thing we're going to talk about today. These domains of composite functions. You have to take the domain of the inside which in this case is the domain of the g function, and overlap it with what? The domain, it has to be another domain, the domain of the whole thing, the composite. So you actually figure out what f of g of x is, and if it ends up being like, x squared plus 6 over 2 or something, then you take this function's domain, this function's domain goes here, and you overlap those two things. The inside domain and the domain of the whole thing you've created. Frankenstein's baby. All right, so moving on. That covers up through problem 4 on your packet. We covered pretty much everything you need to know through there. Flip it, please. Look at problem 5. F of x and g of x are these two things. Then find f of g of 2. This is really pretty easy, because you start by finding g of 2. Just put 2 into the g function and you'll have an answer. It'll come out to like 8. And then take f of that. I'm not saying it actually is 8, but figure out g of 2 first. Well, what is g of 2? On problem 5, the g function says 7x minus 4. So if I'm figuring out g of 2, I stick a 2 in here. 7 times 2 is 14. 14 minus 4 is 10. I just figured out that they really wanted to have me put a 10 here, because that's what g of 2 is, 10. Now it's really just f of 10. All right. Okay, I think that gets you through at least 3 pages, and there's more that I've covered here of your packet. That is not half. I know that. I can't get through everything in 2 days. It's impossible.